So I wanted to show one final example of how to be able to find a confidence interval for one mean when the population standard deviation is unknown. Now clearly, in this example, the only thing that we're shown thus far is we're shown that we have just a number of samples. Okay, so we just have these samples. If all you're given is samples, then we don't know what sigma is. Okay, but we can find x bar, we can find s, and we can find the rest of the items to be able to find our confidence interval. All right, so the first thing that we need to do, we need to be able to figure out the 5 variables that govern our confidence interval. So we need x bar, we need s, we need n, we need the confidence level, and then finally we need t critical. Okay, and t critical is based on the previous two. Okay, the degrees of freedom as well as the confidence level. Now, to find x bar and s, okay, what we're going to have to do is we're going to have to use a calculator function. All right, so what you're going to do is you're going to go under stat, and this is for a TI-89 or TI-83 or 83 or 84, stat, and then edit, and then you're going to enter all the data into list 1. Okay, so just hit 97, enter, 45, enter, 78, enter, 87, enter, etc. Right? Then proceed by hitting stat, calc, and one var stat. Okay, and you should get a screen that shows you everything that you need. Okay, so I went through and did this. All right, and here's what I got. So stat, calc, one var stat. I got that x bar is 97.545. I'm sorry, 79. 79.545. S, which is really SX in the calculator, that's going to be equal to 15.456. N, you can either get N from the calculator or you can just count that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 observations. Confidence level given in the problem as 90%. Degrees of freedom, n minus 1 is 10. Confidence level is 90%. We're going to go to the chart and we're going to find what T critical is. Okay, so we're going to go to the bottom. We're going to look at 90%. We're going to go up to 10 degrees of freedom. I got 1.812. Okay, so, and this is a really good example of something that somebody would do in real life. Okay, so this is more applicable to what somebody would do is if they just collect raw samples and they want to predict what the true mean is, okay, with a specific level of confidence. Okay, so now let's go forth and figure out what the margin of error is and then figure out what the 90% confidence interval is. Okay, now remember our formula, margin of error is equal to plus or minus T critical times S over square root of n. Well, in this case, T critical is 1.812 times S, which we just found to be 15.456. And we're going to divide that by the square root of n, which is 11. Okay, there's a plus minus in here. And that's going to be plus minus, I'm going to type this in my calculator if you can verify along with me. I end up with 8.444. Alright, so that's our margin of error. That dictates how wide our confidence interval is going to be. Okay. Now, finally, we're going to find the confidence interval. Okay, remember our confidence interval is x bar plus or minus the margin of error because it dictates the width. And in this case, that's going to be x bar, which we found to be 79.545. We're going to plus or minus 8.444. You do minus first, you compute plus second. And again, if you can verify this by going in your calculator and doing the same, I got 71.011 as the lower bound. For the upper bound, 87.899. Okay. Now, the final thing we have to do is we have to interpret this. The last time I tried to do this, it didn't like me too much. This time it seems to be liking me a little bit. So we can state that we are 90% certain or 90% confident that, sorry, spelling error, that the true mean Math 216 score, exam score, if we go back up here, exam score for Math 216, Math 216 exam score is between 71.011 and 87.899. All right. Notice that this is a much wider interval than some of the ones we've seen so far. That's because we only have 11 samples. All right. If we had more samples, we would get a much wider confidence interval for this. All right. So make sure that you're okay being able to do this. Go back, practice those two, look at the assignment problems, and then before we move on to the confidence interval for one proportion, make sure you're competent with this.